All right, we can go ahead and get started. Welcome back, everybody, to the UTIG discussion hour. For this semester, we're going to keep going with everything on Zoom just because of kind of the state of Austin and how well it worked out last year. But maybe next semester we'll be able to see each other in person again. For our first presentation, Gail Christeson is going to tell us about doing field work during the pandemic. Pretty sure most people probably know who Gail is, but she is senior researcher at UTIG and the associate director. So take it away, Gail.
Okay, yeah, so I'll be talking about some pre-expedition drilling during the pandemic for our South Atlantic Transect project. So just a brief background on the South Atlantic Transect. This is a multidisciplinary investigation, scientific ocean drilling through IODP along a crustal flow line across the western flank of the southern mid-Atlantic ridge. So here's the mid-Atlantic ridge. Here's South America, Africa, and we'll be doing a transect to acquire data at ages 7 to 61 million years. So there are three components to the project. The first is hydrothermal evolution of the aging ocean crust. So this will require us to core basement rocks. Then the microbial community variation with increasing substrate age. And this is both in the sediment and in the basement. And then the paleoceanographic evolution of the South Atlantic Ocean, which will be pursued through the sediment. So these two expeditions, 390 and 393, were scheduled. The first for the fall of 2020 and the second for the spring of 2021. So what happened during 2020? Well, the first thing that happened was the JOIDES Resolution, the drill ship, actually needed some repairs. So in March 2020, the drill ship was in Panama, and it had to undergo extensive repairs and upgrades of this derrick, including replacement and strengthening of some of the members. So that was scheduled to happen. So the ship was in Panama when the pandemic really started to hit the rest of us. And then the other thing that happened was during the same time period, it was recognized that there were some leaks in 3 thrusters. So that required a dry dock. And the dry dock ended up being in Amsterdam in June of 2020. So, so even without the pandemic, there were some issues. So 2 expeditions were postponed because of these repairs. And there's also some problems with getting a permit for drilling off Brazil. But some expeditions were added because of these cancellations. So they thought maybe they could get some engineering testing done, which had already been postponed. And then they added a Reykjanes mantle expedition. But then both of these expeditions were postponed because of COVID. And the engineering testing was rescheduled for July, September 2020. And the idea was to continue to plan to implement each expedition until it was clear that it wouldn't go because of logistics or safety. So that was the situation in summer of 2020. So we started to get involved for our expeditions with COVID mitigation protocol planning. So the science operator developed this mitigation protocol for operations during the pandemic while the vaccines were not yet available. And there are things, you know, having to do with quarantine and whatnot. But one thing that was really going to affect us was that there was going to be a reduced shipboard scientific and technical staff. So basically by 50%, all people would have single cabins, all scientific and technical staff. So we started meeting via Zoom to identify who would be the essential personnel that would be on board with the idea that there would be a later shore-based sampling party with all the scientists. So that's, you know, what we did for Chicxulub. We had a very small science party, and then later everybody came together to do the sampling. So even doing this exercise, we ran into a lot of problems. The first was there were a lot of ephemeral measurements, you know, that had to be taken on the ship. So this meant we would need all the microbiologists and all the organic and inorganic geochemists. But we also needed some of the other specialties, petrologists, micropaleontologists, et cetera, to guide operational decisions, because these were multidisciplinary expeditions. So this was really hard, trying to get things down to 50%, and the technical staff as well. So we started, we did this exercise, and we started contacting the science party with letting people know whether they were going to be part of the shipboard science party or not. And we just started getting a lot of concerns about being able to travel from some of the countries. The South American port was changed from Brazil to Uruguay, but even to get to Uruguay, it seemed like you often had to go through Brazil. So it wasn't soon thereafter that the first expedition 390 was postponed. And then at the facility board meeting, the other expedition 393 was postponed. So what happened in their place was the facility board decided that, you know, it was going to just be very difficult to implement an expedition with a science party, even a partial science party, because there are so many international participants. It was just logistically very challenging. So, so instead, they looked to see what could be done with the ship with a limited technical staff and crew that could help advance some of these expeditions. So support scientific ocean drilling even during the pandemic. And since our expedition was in international waters, there were no permits that were involved. And so the facility board came up with an idea that the ship would go down and install some of the equipment we needed for our drilling. So this would be the re-entry cones and casing. And I have the next slide, I think, shows what this involves. So the expedition left from Norway and came all the way down to the South Atlantic. And you can see the days on here. This was, you know, like almost a month, right? Spent 32 days on site. While out here, the COVID situation changed such that originally the ship was going to go to Las Palmas afterwards, and instead it went to Cape Town. So that actually increased the number of days on the site. So it was here for 32 days. And there were regular Zoom calls with the co-chief scientists to go over operations. So now I'm going to show you what this re-entry system is. I turned off the cheesy music, so you don't get the music. So this will be quiet. But so this is going to show you how this re-entry system works. So that's the drill ship. And what we'll see here is what's called the moon pool. Okay, so this is the base of the re-entry system. So this was what will sit on the seafloor. So the casing string. So you can see this takes a lot of work to assemble this because especially with the water depths, right? So we were in several thousand meters of water. Okay, and then this is this hydraulic release tool. So the key thing is that you're going to put down this casing string and a re-entry cone. And what that does is the casing string stabilizes the hull so that you don't have like soft sediment falling into the hull. So you need that when you're going to do a lot of re-entries to do the basement drilling. Okay, so what are we seeing now? So this is the drilling assembly. So there's this mud motor, this under reamer, and a drill bit. So this will go down to the seafloor and drill the hole. Okay, so the casing was already is down here in yellow. Then this drill string is lowered through it. So this is going over this hydraulic release tool. So here's the reentry funnel. So this is so that you can, once you establish the hole, you can go back and get the drill string through it. Right, so here everything's going down. So again, yeah, so that'll sit on the seafloor. Here's the drill bit. This is called the under reamer. Right, so it's making the hole wide enough for the casing. So then the casing goes right in. So this is called a drill-in casing. Then you get the that little base. This is I like this part of the animation, this little go devil. So this goes down, and this was what actually will release the equipment from the reentry system. So here it comes. And now you can bring the drilling assembly back to the drill floor. So you can see there's quite a lot that's going on here. And this was what was planned for this expedition without a science party, to get these reentry cones installed for us so that when we go out, we could just do the drilling. Okay. All right. So that's the idea. So I'll show you what actually happened. So these are our oldest sites. So what we're seeing here is a seismic section. This layered stratigraphy is sediment. And then the lower frequency material here is the top of the ocean crust, the basement. So we had two sites at the oldest age, one in thin sediment and one in thick sediment. And these are very high priority sites. So they went here first. So this first one, 1556. So the first thing you have to do is you have to core through the sediment so you know how much casing to install. Because if you saw from that video, the guide base, the reentry funnel was at the top of the casing. So if you don't get the casing right, it wouldn't be on the seafloor. All right, so first you core through the sediment. So this site did that and encountered hard rock at 278 meters below the seafloor. This was actually deeper than I had expected. So I thought the basement was, up here where these low frequency reflectors are, and it turned out to be down here. So anyway, drilled, it contacted basement, and then the ship moved, brought the drill string up just above the seafloor, moved over here, drilled through the sediment here. So that was encountered hard rock at 564 meters below the seafloor. Drilled the reentry cone and some casing into the sediment at this thick sediment site to 64 meters below the seafloor. So this had to be done in two parts because the weight of everything with this great water depth, which is like 5,000 meters, and then 564 meters of sediment meant that you want to case this whole thing. So it needed to be done in two steps. So So we drilled the casing, the first casing below the seafloor with the reentry cone. But at this point, the subsea camera failed. And this camera is required to do operations with these reentry systems. And so operations couldn't be completed at these two sites. But we did recover this nice basement rock. So this one is especially nice with these look like calcite veins, another interesting material. We haven't seen them yet. Okay, so this is what happened at these two oldest sites. So next went to the next site over 49 million years, drilled through the sediment, got a nice contact. Here you can see the beautiful sediment basement contact at 159 meters below the seafloor. But then ran into some issues. So we drilled the sediment, and then two holes we're trying to drill in the casing, but releasing from the casing just wasn't working. So the entire assembly had to be brought back up, tried it again, so it failed twice. And finally, this was the first time they had tried to do this into basement. And decided that this assembly from where the bit sits in the hard rock to what's called the running tool was just too rigid. And, you know, they tried many hours to do this. So eventually they took out one casing length, and they successfully installed the casing, but above the basement. So 30 meters above the basement. So it'd be better if it was in the basement because you really want to case off the sediment. But this is what they're able to do. And the subsea camera failed again, and there was a partial fix at sea. And this was obviously pressure induced failure. So there was reduced resolution, but at least they were able to get some visualization. All right, and then the last thing that was done was went to the youngest site. And this was very simple, cored through the sediment, 64 meters, installed the reentry cone and casing, but slightly above the basement. So all in all, didn't achieve everything you'd want, but it was really great because this was all bonus to our expeditions. So cored over 1,000 meters with a pretty good recovery in the sediments and a little bit of basement. Okay, so we were like, well, that was great. We haven't had our expeditions. Obviously, there were some issues that were encountered, so it was great that they were encountered now, and it'll make things much easier when we go out. But then the facility board decided they'd actually complete the installations for us. So they added this expedition. They called it 395P to go and complete our installations. So the idea was to come to the second youngest site, and then the third youngest, and then complete the operations at these two oldest sites. And also fix the subsea camera while in port. And if there was time, even do some logging. But despite quarantining for 5 days in port and having negative COVID tests, 2 negative COVID tests in port, one person did come down with COVID, and it happened after they boarded the ship. And this person was likely exposed during the travel to the port. And even with all the protocols, the masking protocols, several other people on board became infected. So this expedition was canceled. The subsea camera was fixed. The COVID outbreak was contained. Everybody was okay. But the ship stayed in port. And then finally, the facility board, really wanted to finish these for us. So they decided that the ship coming from South Africa back to Reykjavik would finish the installations. So again, the same procedure. The departure was delayed a bit because of issues just getting personnel to the port. So there were only 22 days on site. Okay, so went to the second youngest site, was able to drill the sediment, got this nice basement, and did the casing. Because of the delay, there wasn't enough time to do one of the sites, so we skipped our third youngest site. Oh, and we do have some results actually. So this is showing the paleomag for that site I just showed, the 15 million year site. And there's here's a preliminary correlation showing here's the declination and inclination and the time scale. And it looks like there's continuous sedimentation, and the age looks about right. So of course we'll need the full analysis. So then went back to these oldest sites and were able to install the casing into basement. Then there were a few delays due to weather. So these two sites, we can correlate the sediments using some of the physical properties on the cores. And it looks like the upper part is duplicated, but the lower section is either condensed or some of it's missing at the shallow sediment site. All right. Our EPM, Trevor Williams, did this correlation with this site here on Walvis Ridge, looking at the magnetic susceptibility. So this is Walvis Ridge, and this is our thick sediment site at 60 million years. And you can kind of see this kind of pattern matches this pattern, and this little peak here could be this peak here. So it looks like, you know, we are getting some of these older ages, including the PETM, which is quite exciting for our paleoceanography colleagues. And then at the end, we had just a little bit of extra time, not enough to do much, but we had a alternate site. So we went and drilled the sediment there. I expected the basement to be down here, and instead we encountered basement after only 46 meters. So I think this is some 3D effects that we're seeing here. So this is that little alternate site. So I think the seismic must be picking up on some of this topography around it, which caused it to be, you know, much thinner than I thought on the image. But we did get some really nice basalt there. So that's exciting. All right, so just to summarize, we had these 2 bonus expeditions during COVID. Because of them, re-entry systems were installed at 5 of our 6 sites, cored to basement at those sites, and got some basic measurements. And this was from the technical staff on board. Measured some physical properties, the paleomag, some geochemistry. So what's remaining? So all those cores need to be described. And these will be brought back to the ship and be described during the expeditions. Depending on, you know, which sites each expedition goes to, we'll describe those cores. We need to do all the basement drilling. We just did the very top of it. And we need complete stratigraphic sections. So we'll have multiple sediment holes and all the microbiology. But we really gained time that can be used to core more basement rocks. And we reduced this time risk by installing the re-entry systems now. And, you know, all the issues we ran into, like the camera and the fact that the drilling casing didn't work when we went into the basement, all this would have been encountered during the expeditions, but now it's already been overcome. And some of the core catcher samples have been distributed to our microbiologists, micropaleontologists, I mean. So here's Chris with some of his samples. So we'll get a peek ahead of the expeditions at, what the ages are that we expect. And we are on the schedule for April to June for the first expedition and June to August for the second in 2022. And so I'll be on the second one here. And so what will we have left to do for these expeditions? So the idea is expedition 390 will be coming from South Africa. So we'll come to our youngest site, drill 2 more sediment holes and the basement. So we're hoping to get 200 to 250 meters of basement. Do the same thing at our second youngest site. So these are closest to South Africa. And then come over to our oldest site and do the shallow sediment one and collect 1 more sediment hole and then basement. And then expedition 393 will come out. We'll do these 2 sites here at 30 and 49 million years. So this one site hasn't had anything that's done yet. So we'll have to do the 3 sediment holes and the re-entry system and the casing. This one I'm quite excited about because there's a lot of evidence that this is the most magmatically robust. Then we'll come to the 49 million year old site and do our 2 sediment and the basement. And then we'll come out to our oldest sites and we'll collect some more sediment and do our basement at the thick sediment. And then the idea is that any time that is left at the end that we've gained by already having these reentry cones is we'll extend basement drilling at one of these sites. And so that's the summary. So I just wanted to thank everybody who made these expeditions possible. So this first expedition, we had the technical staff, all the crew, and we had our one expedition project manager who had to work on all the reports by herself. And this expedition, we didn't even have the expedition project manager because he had flown all the way to South Africa for that expedition that was postponed. And so they decided they could do this one without him. So this was done through a lot of Zoom calls. Okay, so I'll stop there and I'll take any questions. Oh, John's giving me a clap. Thank you, John.
How do you feel like it went, all things considered? Was it pretty easy to communicate through Zoom, even though that's probably not ideal on a ship?
It actually wasn't bad because of, so often there's like a whole science party and there's a lot of people, using the internet, but so I think there was less internet usage. So I think that helped. But yeah, we were able to communicate pretty well. I mean, occasionally we got cut off, but we were able to make the big decisions. Sean, have you done any of the reentry cones?
We did that on one of the Nankai legs I was on. We were doing reentry cone work. Yeah.
Yeah, whenever you're doing something like that, there's always something that can go wrong. So it was really nice to get those done now.
Yeah, because one of them, it took like 3 days out of the operations, and that limited what we could do for just one site.
And I know Brian, Brian was supposed to go on one of the Brazil expeditions that was postponed.
Yeah, still postponed. People are cautiously optimistic. I'm very pessimistic. I don't think it's ever going to go. But yeah, it's interesting to see that. I wondered the engineering in terms of how do they fix the camera? Is that happening real time on the ship? Someone changes some part of the engineering, or is that happening in port?
So they were able to do some little fix on the ship that didn't give them full capability. And then in the port, they actually flew in someone who had retired. You know, that's the way all this equipment always is, right? So someone who had retired, who knew about the equipment, and he came in and did a fix. So it was something that was happening with the pressure. Something was staying open, and so they needed to fix that. But for your expedition, Brian, yeah. So the problem is that Brazil doesn't allow drilling. Even scientific ocean drilling, but there can be exceptions. And in the past, there has been that exception, but right now the Brazil Navy is blocking it. But there seems to be some inroads, so there's a little bit of positivity that might be overcome.
Yeah, interesting. I mean, I think that they actually had the sort of non-official but effective approval, but then with the current administration, they saw a chance to really clamp down and not allow the Brazilian administration. So I think it was highly political, actually, even though I think they probably had done everything that was required. But in hindsight, they sort of introduced this new, well, you really had to clear this law from wherever the 80s or something that you haven't done, even though that had never been on the table for the years and years leading up to it. Anyway, yeah, so that's good to hear that there's some positive enthusiasm for it.
Yeah, I just got an email from Tom Junkley Jones, who's one of the co-chiefs today, who basically saying that, you know, there's a chance it could go in the final round of proposal or expeditions.
Yeah, I mean, so yeah, these expeditions that were postponed, like ours, they you know, once they've been scheduled, they want them to go, you know, rather than, you know, like right now, if it could go, I think they would do the Brazil ones instead of adding new expeditions instead.
Agreed.
But they're not going to do it until they have those permits in place. They're not going to deal with it again.
Yeah. That's 387 and 388, right? Expeditions. Yeah.
Yeah, and the engineering expedition that went was interesting because it was testing some drill bits for hard rock drilling. So industry has a lot of drill bits, and some of them look really fancy. So they were trying those out to see whether they could get better recovery in hard rock, but there really weren't any game changers with them because it's really hard to drill on a ship that moves compared to drilling on land. So what works for industry doesn't really work for us.
Well, it's too bad it wasn't a game changer because there was a lot of hope that those new bits would make a big difference.
Yeah, but they did test, and we used this XCB cutting shoe. And so if you notice some of our samples, the contact between the sediment and the basement was really quite nice. So it won't drill very far into basement, but it did have really good recovery for the part that it could get through. It's just very, very slow.
Yeah.
All right. Any more questions for Gail? Well, cool. Thank you guys for coming. Thanks, Gail, for presenting.
Thanks, everyone.
Thank you, Gail.